So according to my notes, section 14, we finished yesterday with this problem right here, right? Am I correct?
Yes.
So let's move on to F, right? Solving a couple more logarithmic equations. And again, right, I'm gonna put up the laws of logarithms. And again, right, just like you should know the laws of exponents, right, rules of exponents, you should know the rules of logarithms. So we have the natural log of x plus 5 plus the natural log of x minus 2 is equal to the natural log of 8. Now in the previous example, right, we didn't have a natural log on the right hand side. Right? I think it was 5. But now we have the real number, the natural log of 8 on the right hand side. Okay. So like before, the first step is to condense the left hand side. And since that's a sum, we're going to condense the left hand side using the product rule. Right? The natural log of m plus the natural log of n is the natural log of m times n. So using the product rule, right, x plus 5 is our m, x minus 2 is our n, and so then by the product rule, this is equal to the natural log of x plus 5 times x minus 2. And that's equal to the natural log of 8. So, we condense using the product rule. Now we have the natural log of this quantity is equal to the natural log of 8. Okay? So you know how in section 5.1, right, we had the 1-to-1 property of exponentials. Well, we kind of have a 1-to-1 property of logarithms. Okay, we got one logarithm on the left, we got one logarithm on the right, and they're of the same base, right? So remember, what goes into the logarithm in math we call the argument, right? It's just a fancy name for the input, okay? And there's like a 1-to-1 property of logarithms, right? The natural log of this argument is equal to the natural log of that argument. And so, since the two logs are of the same base, right, they're both of base e, the arguments must be equal. Okay. So, the argument on the left, x plus 5 times x minus 2, has to equal the argument on the right, 8. Well, now you can see this is shaping up to be a quadratic function, right? When we FOIL the left-hand side, we have x squared plus 3x minus 10 is equal to 8. And now when you subtract 8 from both sides, we have x squared plus 3x minus 18 is equal to 0. And now to solve for x, right, you can either factor or use the quadratic formula. And this factors into x plus 6 times x minus 3. And by the zero product property, either the first factor is equal to 0 or the second factor is equal to 0. And so we have x is equal to minus 6 or x is equal to 3. So again, similar to yesterday, it appears we have two solutions to our original equation, right? Do we have two solutions or just one? Just one. Which one's extraneous? Negative 6, because you put a negative 6 in for x here or here, you end up taking the log of a negative number. And you can't do that. It's undefined. So only x equals 3 works. X equals minus 6 is an extraneous solution. Okay. Any questions on that, ladies and gentlemen? All right, let's take a look at the last one. We have log base 3 of x plus log base 3 of x minus 3 is equal to log base 3 of 40. So again, we condense the left-hand side using the product rule. And then again as before, okay, we have a logarithm on the left, a logarithm on the right. They're of the same base. And so since the logarithm on the left and the logarithm on the right are the same base, their arguments must be equal. So the argument on the left is x times x minus 3, and the argument on the right is 40. So we have x times x minus 3 is equal to 40. Arguments must be equal. So that again is shaping up to be a quadratic function. So when we distribute the x inside the parentheses, we have x squared minus 3x is equal to 40. And then when we subtract 40, we have x squared minus 3x minus 40 is equal to 0. And you may take a moment to figure this out. Joe, do you know what the factors are? Yeah, -8. The factors are x minus 8 times x plus 5, right? So it might take a second to think about, okay, what two numbers add to -3 and multiply to -4? Okay. And eventually you come up with -8 and 5. So, what is zero product property? X minus 8 is equal to 0. Or x plus 5 is equal to 0. So that means x is equal to 8, or x is equal to -5. And again, it's the negative value of x that's extraneous. Okay? But that doesn't always have to be the case, because if this was minus x here, or 3 minus x here, the negative number would be the solution, and the positive number would be extraneous. So you got to plug both in to determine which one is extraneous. So -5 doesn't work, and we're left with x is equal to 8. Any questions on that, ladies and gentlemen?
Can there be an instance where both the solutions are extraneous?
I have not ever seen one. Okay? That would mean that there's no solution to the original problem. And I have never seen that situation. Okay. I mean, that would have to indicate there's no solution to the original problem. And I just can't imagine what kind of problem that would be. All right. Any other questions? All right. So I sent out the email. The 4 problems on page 3, right, are on video. I think it's a short video, if I recall, 8 minutes or something like that. Okay. And I had a student in my office yesterday, and you know, because I talk so slow, if you increase the speed from normal to 1.25, you can still understand everything I say, right? And I'm not going 1,000 miles an hour. I'm talking like a normal person if you speed the video up. Okay? So you might entertain that idea. Okay? Increasing it to 1.25. Okay. All right. This material on page 4 is actually section 5.2 material, but that section was long enough that we put it on 5.3. Okay. All right. So we're going to find the inverse of a couple of one-to-one functions, and they both involve, the first one involves a natural exponential function, and the second one involves a natural log function. So just as a reminder, okay, and so for those of you that take Math 120, these two functions really need to be as familiar to you as the square root function or the squaring function, right? Things of that nature. So remember, the natural exponential function, its graph looks like this, right? Y equals e to the x. Crosses the y-axis, x equals 1, right? We've done all this already. And the natural log function, its graph crosses the x-axis at x equals 1. And remember, these two guys are inverse functions of each other, okay? So they have the property, right, the properties, the natural log of e to the x is just x, and e raised to the natural log of x, right, is just x. So in A, we're going to find the inverse function of f of x equals e raised to the 3x minus 1 plus 5 power. Or, let me rephrase that, I said that wrong. E raised to the 3x minus 1 power plus 5. Okay. So f of x here is just a transformation of the basic exponential function. Okay. And you know that the domain of the natural exponential function, okay, is all real numbers. Right? There's no minimum x coordinate, there's no maximum x coordinate because it goes up and to the right. It goes to the left. Right? So the domain for e to the x is all real numbers. Okay. So f of x here is just a transformation of this function. And when we replace x with 3x minus 1, okay, one thing it does is it's going to shift the graph to the right. Okay, I'm thinking about this 3 right now here, how it affects the graph. Okay, but this can be written as e raised to the 3 times x minus 1/3 power plus 5. Okay. Actually, when you replace x with 3 times x, it condenses the graph horizontally. And we did not consider condensing or stretching horizontally. We only considered condensing or stretching vertically. Okay. So, but what happens, even if it gets condensed horizontally, it still goes to the left forever, it still goes up and to the right forever. It doesn't change the domain. Okay. And when you replace x with x minus 1/3, you know it shifts the graph to the right 1/3 units, but that doesn't affect the domain because it still goes to the left forever and up and to the right forever. So the domain of f of x remains all real numbers. Condensing the graph of y equals e to the x horizontally and shifting it to the right and shifting it up 5 units, right? That's what the plus 5 does, right? Shifts it up 5. It does not affect the domain. It still goes to the left forever. It still goes up and to the right forever. That's important information, okay? All right. So now to find the inverse function, you know there are 4 basic steps. Step number 1, replace f of x with y. Step number 2, switch x and y. So if x is equal to e raised to the 3y minus 1 power plus 5. Step number 3, solve for y. So we can subtract 5 from both sides, 5, right? Move the 5 from the right side to the left side by subtraction. And we have x minus 5 is equal to e raised to the 3y minus 1 power. Now, whenever you have to solve for a variable that's an exponent, you're going to need a logarithm, right? We gotta solve for y. It's an x in the exponent. We're gonna need a logarithm, right? That's what 5.2 was all about, right? We had to solve the equation x is equal to a to the y power. There's no algebra, so they created the logarithmic function as the solution, right? So we got to get rid of e on the right hand side. What gets rid of e? Over here, this property over here, right? The natural log of e to the x is just the exponent x. So we can take the natural log of both sides. We have the natural log of x minus 5 is equal to the natural log of e raised to the 3y minus 1 power. Well, instead of x as my exponent, I have 3y minus 1, right? So this just simplifies to 3y minus 1. And now we're solving for y, right? So we can add 1 to both sides, right? Move the minus 1 to the right-hand side by addition. And I like to put the 1 in front of the natural log. So I don't confuse it with the argument going into the natural log. Okay? And now we divide both sides by 3, and we have 1 plus the natural log of x minus 5 divided by 3 is equal to y. And the last step is replace y with inverse function notation. So we switch the two sides, and we have f inverse of x, right? That's the inverse function notation, is equal to 1 plus the natural log of x minus 5 over 3. Use interval notation to state the domain and range of the inverse function. Okay. So does anybody have any questions? Okay. On how we got the inverse function? Right. Same 4 steps, right? We studied inverse functions, what, back in section 2.8, chapter 2. And it was 4 steps. Okay. Well, the domain of the natural log function, you know, is all positive numbers, right? X has to be greater than 0. X can't equal 0 or a negative number. So the right-hand side here, involving x, is just this natural log right here, right? So the natural log of x minus 5 determines what the domain of the inverse function is, right? Remember, the domain is the numbers you can put in for x. And so at the end of 5.2, we were finding the domain of some log functions, right? So how do you find the domain of a logarithmic function? You take the argument, which is x minus 5 in this case, and you set it greater than 0. And then you solve for x, right? The 1 and the 3 are irrelevant. The only thing that's relevant in this function and finding the domain is the natural log of x minus 5, because that's where the variable x is. And so to find the domain of a logarithmic function, you take the argument and you set it greater than 0. And so when we solve for x, we get x has to be greater than 5. And so in interval notation, the domain is 5 to infinity. So that's what you can find the equation for the inverse function. Use it to say the domain range of the inverse function. So the domain of the inverse function is 5 to infinity. Okay. Now, in determining the range of the inverse function, you got two ways of looking at this. The range of the inverse is equal to the domain of f of x, right? So, what's the domain of f of x? All real numbers. Okay. The other thing, other way you can look at this is the graph of y equals the natural log of x, right? And its domain is minus infinity to plus infinity, its range is minus infinity to plus infinity, right? The y coordinates. Well, this is just a transformation on this function. Replacing x with x minus 5 just shifts it to the right 5 units, right? The whole graph to the right 5 units. So it still goes down forever and still goes up forever. So that doesn't affect the range, shifting it to the right. And this other stuff, right, just shifts the graph 1/3, shifts the entire graph up 1/3 unit. Multiplying the natural log by 1/3 compresses it by a factor of 1/3. None of that affects the minimum, right? There's still no minimum y coordinate. There's still no maximum y coordinate. So you can look at it two different ways in getting the range. So the range, the first way, the range of f inverse is equal to the domain of f of x, and the domain of f of x, right, we deduced is all real numbers. There you go. All right, any questions? Yes, ma'am.
So for the domain, are we always going to be using the argument to find the domain of the inverse?
Well, when you're finding the domain of a function that has a natural log, that has a logarithm in it, then you have to set the argument
Even
clear
if
to.
it's log 2?
Yeah.
Okay.
Log base 2, log base 10, log base 12, whatever.
Okay. And then for the range, there's not really any math behind it. It's kind of just.
Well, we deduced from the graph of y equals e to the x that the domain of e to the 3x minus 1 plus 5 was still all real
So
numbers.
kind of just knowing those graphs.
Yeah.
Range.
And that's very important if you gotta take math 120. Yeah. If you understand what the graph looks like, that can answer a lot of questions for you. Okay. All right, any other questions, ladies and gentlemen? Okay. All right, let's take a look at B. And now we're going the other direction. The one-to-one function is a transformation on the natural log function. And now we got to find its inverse. Okay? So this is a transformation on the natural exponential function, and its inverse, right, is a transformation on the natural log function. Now we're given a transformation of the natural log. What do you think its inverse function is going to be a transformation of? The natural exponential function. Okay. So we have f of x is equal to the natural log of x plus 3 minus 1. Can we find the domain of that function? How do we find the domain?
Set it greater to.
Yeah, this is the argument, right? So to find the domain, you set the argument greater than 0. So the domain of f of x, you set the argument greater than 0, and when you solve for x, you get x has to be greater than -3. If x equals -3, you put -3 in for x, you got the natural log of 0, and that's undefined. If x is less than -3, like -4, -4 plus 3 is -1, and the natural log of -1 is undefined. So x has to be greater than -3. That's the domain of f of x in their whole notation. So do we automatically know the range of the inverse function now? Yeah, because we know the domain of f of x. Okay. All right. So to find the inverse function, same 4 steps. Replace f of x with y. Then switch x and y. Right? You guys did this on exam whatever, right? With a rational function. Okay. And now we got to, what did I do? That doesn't make any sense. Okay. So we switch x and y, and now we got to solve for y, right? So we can move the -1 to the left-hand side by addition. We have x plus 1 is equal to the natural log of y plus 3. Now y is part of the argument into the natural log function, right? So how do we get rid of the ln? E, right? E raised to the natural log of x is just x. So we can make the left-hand side equals the right-hand side. So by the one-to-one property of exponentials, we can make the left-hand side an exponent on the number e, and we can make the right-hand side an exponent on the number e. Okay? Exponential on the left, exponential on the right, bases are equal, so the exponents must be equal. X plus 1 must equal the natural log of y plus 3. Right? So we haven't violated it. Well, on the left, we have e to the x plus 1. And by this property of the natural log, e to the natural log of x is equal to x. Right? Where x is the argument into the natural log function. Well, the argument here is y plus 3. So the right-hand side is just equal to y plus 3. And now we can solve for y on the right by subtracting 3 from both sides. And so I'm going to put -3 in front of the e. So we have y is equal to -3 plus e to the x plus 1 power. And now we switch the two sides and replace y with inverse function notation. And so f inverse of x is equal to -3 plus e to the x plus 1 power. So, the range of the inverse function is equal to the domain of f of x. And what's the domain of f of x? All real numbers greater than -3. Now, you could have also gotten the range by noting that the inverse function is a transformation on the graph of e to the x, right? When you replace x with x plus 1, it just shifts the graph to the left 1 unit, right? And then when you subtract 3, it shifts the graph down 3 units. So the range, instead of going from 0 to infinity, now goes from -3 to infinity. The domain, again, this is just a transformation on the natural exponential function e to the x. So when you replace x with x plus 1, it shifts the graph to the left 1 unit. That doesn't affect the domain, right? It still goes from -infinity to infinity, right? And then when you shift the entire graph down 3 units, it doesn't affect the domain because it still goes to the left forever and up and to the right forever, okay? And so the domain of f inverse of x, right, is all real numbers. This is where the transformation of functions back in section 2.2 comes in really handy. If you understand that this is just a basic transformation on y equals e to the x. Any questions on that, ladies and gentlemen? Yes, ma'am.
It's kind of like a weird one. I don't know if it's gonna make sense. So, kind of like every time that like the form is going to start as y equals e of x, the range will end up being all real numbers, and then vice versa. So like when for this problem, the form ended in like kind of like a graph that would be similar to like y equals e of x.
Right, transformation of it.
And it's all real numbers.
The domain.
Right. And no matter what like transformations it's going to have, if it's in that form, it's going to be all real numbers.
I think so.
Okay.
Yeah. Okay. All right. Any other questions?